Ladies and gentlemen, thank you for standing by and welcome to the Power of Automation Rapidly Deploy on OpenStack Cloud webinar. During the presentation, all participants will be in a listen-only mode. Should you wish to ask a question during the presentation, please use your chat feature located in the lower left-hand corner of your screen. If you need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded Thursday, September 24th, 2015. I would now like to turn the call over to John Janechik from Mirantis. Please go ahead.
Good afternoon, ladies and gentlemen. Thank you for joining us. I'm John Janechik, and I work in technology solutions marketing at Mirantis, specifically with our unlocked partner ecosystem, which is the name that we give to a large group of technology partners providing hardware, software, middleware, and stack component solutions, which they integrate with our OpenStack distribution. We're a pure play OpenStack company. Our singular focus is on OpenStack. So one thing that you can know about us is that we work on OpenStack with no agenda other than to make OpenStack better, both for the community, because we upstream all of the work that we do eventually to Trunk, and to those who want to use OpenStack in the way that OpenStack was philosophically and technically intended to be used, as an open platform for building clouds with user-selected, best-of-breed platform and software and stack components. We're, as of Juno, and these are really 2014 numbers, we were the number 3 contributor to OpenStack itself, and we contributed most heavily to products in which we have particular expertise and interest, Fuel, Murano, Sahara, and Rally, which will be discussed in some detail today, so I won't discuss them now. Our approach to partnering and opening up OpenStack is to remain 100% vendor agnostic. We work with some dozens and soon to be some hundreds of partners across the global ecosystem. OpenStack contributors, people who work in the Linux space, makers of operating systems and hypervisors and platform technology and storage, SDN, and other solutions to make it easier for them to attach reliably to OpenStack and to deliver a robust cloud with their solutions on board to their customers and to our customers. This is really more of the same information, so I'll just skip on. Today's topic, or at least our first topic, is Fuel, which is a project that Mirantis started, but is an open source project to which anyone can contribute. Fuel is an open source deployer, and it forms part of a Mirantis stack, a loosely coordinated stack of solutions for automated deployment and rapid solution delivery and end-user self-service and rapid setup of DevOps and continuous integration, continuous deployment systems for software, agile software development, for manual and auto-scaling of applications, for managing singular and hybrid clouds, and moving up the stack to higher and higher levels of platform abstraction. And of course, Fuel becomes a method that lets Mirantis customers rapidly deploy clouds on a pluggable system to allow partner products to participate in these deployments and be rapidly deployed and scaled. Where Fuel lives is next to the cloud from pre-deployment. When you download Mirantis OpenStack, which you can do for free, you get an ISO which can be installed in a low-profile virtual machine, which is on the same network as your pile of hardware. That ISO will deploy what's called a Fuel master node, which loads essentially hands-off starts up a DHCP and PXE boot server and lets you log into a web interface from which configuration and deployment of OpenStack on your hardware can proceed. If you make only the plain vanilla default selections through the Fuel wizard, it takes under a minute, I would say, from the moment you first log into that web interface to the point at which you're ready to make the bigger decisions on which your desired reference architecture will deploy. You will be, by that point, your nodes will have been auto-discovered. You will have been given opportunity to assign roles to them. Do you want these to be compute nodes in an HA configuration? Which nodes do you want to be, I should say, controller nodes in an HA configuration? Which nodes do you want to be compute or compute storage? Which nodes do you want to be pure storage or take on other functions, for example, as operating system only nodes in a future SDN deployment? Fuel gives you all of these options in a fairly point-and-click, drag-and-drop interface, which has recently been upgraded in our version 7.0 due to general availability at the end of next week. Excuse me. The Fuel user interface also gives access to some fairly fine-tuned controls. You can control, for example, the layout of disk drives on controller and compute and storage nodes fairly finely. You can control pretty much anything about the core virtual network layout of your cloud by typing in IP addresses and CIDR ranges. It does become a little bit technical. That is to say, Fuel can do some thinking for you, but a certain familiarity with how OpenStack goes together is required to use it optimally, certainly to deploy a production cloud. You have to have an idea of what you're doing, or at least be following a good recipe. But operationally, it makes the process quick and effortless, at which point you click deploy and you walk away and have a cup of coffee, and 40 minutes or so later you have a cloud on which you can then run health checks, on which you can perform preliminary smoke tests, and then use Fuel as not exactly as a lifestyle manager, but as a method, for example, to aggregate logs for support conversations and otherwise structure your interactions with Mirantis support or third-party support providers for your cloud's operations. What Fuel primarily does is deploy reference architectures. Mirantis is an integrator with a great deal of experience building clouds for other people, including some of the biggest OpenStack clouds now running for major carrier clients and similar entities. Clouds that are hundreds or in some cases 1,000 nodes deep. And what we have tended to do is take the intelligence that results from these successful deployments and bake it back in first to our own distribution and then to upstream, so the entire OpenStack community eventually takes benefit from the work that we're doing with customers in the field, making OpenStack run well at scale. In the opposite direction, we have developed not prescriptive deployments of OpenStack, because of course you can completely customize your deployment and do anything you like with OpenStack. But deployments that we have found work well for specific ranges of use cases. And what Fuel does is optimally deploy these use cases. So these what we call reference architectures. They're not reference architectures as those would be described in common parlance, in that they're not particularly prescriptive, but they do describe what we call configurational hardening of OpenStack, things that you do to configurations to tweak better performance, more robust performance out of the open components. So fundamentally, what we're doing is deploying what we know works while allowing you to customize that to the platform and third-party product and other requirements of your particular installation. As an example of what a reference architecture might comprise, and in fact this reference architecture does not yet exist in Fuel, but no doubt in the fullness of time, probably in the Liberty time frame, it will come to exist, is something that we released last week, which is a Mirantis OpenStack NFV reference architecture, which is based on the ETSI NFV reference model. This is a way of using Mirantis OpenStack reliably at scale to provide virtual network functions and chain virtual network functions for telco operators and service providers. As you can imagine, that is potentially both a very high performance and a potentially very high scale application. And this would be the kind of model that would be fully optimized and is indeed being optimized now with our carrier customers who are using this product. And will be further optimized over the next 6 months and will eventually appear in Fuel as intelligence that can be exploited in deploying an enterprise cloud, for example, or a smaller scale version, or another service provider cloud at large scale. Just to sort of summarize, Fuel performs configuration and deployment on essentially arbitrary standard computing infrastructure. It works since our version 6.0 from authoritative repositories rather than carrying all the changes on board. So what you're getting when you deploy is at least optionally the latest and greatest of our release software. It performs automated deployment via a pluggable architecture of OpenStack partner products. So for example, you'll hear in a little while from Ed about how Fuel Plugin can be used to deploy SolidFire solution underneath OpenStack to provide ultra-high performance stable flash storage. The Fuel system can also be used in various ways to facilitate deployments of MOS certified drivers. That is to say, you can go to driver log or another repository of OpenStack drivers for components that may or may not be part of our partner ecosystem, and use Fuel in various ways to aggregate deployable artifacts from those people and facilitate deployment of those solutions. So even if there's not a plug and play one button quick insta deploy option such as is provided with a Fuel plugin typically, Fuel is still serving as a way of facilitating and standardizing deployment of OpenStack compatible as opposed to Mirantis partner products. Fuel lets you scale up your cloud. It lets you add nodes and make course changes to configuration. It works as a jump server, which is actually, I find, as somebody who builds clouds all the time, remarkably convenient, because it means I don't have to remember a whole bunch of IP addresses in order to log securely into the nodes of my cloud. I can just log onto my Fuel server and jump straight to the nodes that I'm interested in. And it works as an aggregator of log information to facilitate support communications. As I noted, we work with the community and we work with partners. The OpenStack certified mark is actually the first mark that we ask our partners to get. So before they engage with Mirantis, we ask them to engage with the community and make sure that their drivers and contributions are compatible with OpenStack trunk, and that they have received from the community the OpenStack certified mark, that they have a CI/CD infrastructure compatible with OpenStack trunk CI/CD, so that their stuff is automatically tested with each change and revision to trunk OpenStack, at which point we can engage meaningfully and at that point very productively with them, because all our systems are based on the trunk systems in order to develop an initial reference architecture for an integration, a manual integration, which is typically published with a runbook, and then let them climb the value stack by developing Fuel plugins or other methods to integrate. For example, software solutions are typically integrated via our Murano application catalog deployer, which lives higher in the stack, and serves certain functions analogous to Fuel as a way of facilitating the acquisition and deployment of the software-only solutions on top of OpenStack clouds. We promote our partners work and compatible work in general very heavily through online resources such as the Fuel Plugins catalog and our partner catalog. So we pull pretty hard to make sure that people are informed of what will run on their Mirantis OpenStack clouds and how things can plug and play. All of our stuff is available for evaluation free of charge. Just look for Mirantis.com. You can do miniature but functional installations of Mirantis OpenStack on VirtualBox, on VMware, on really any kind of system of desktop or cloud virtualization, and depending on how many resources you can afford to throw at them, these things can become quite close to production in capability. I frequently do fairly heavy software testing on a VMware ESXi enabled, entirely virtualized version of a Mirantis OpenStack cloud. So I know. And with that, I think I will hand the baton to you, Ed, and you can go on and show them exactly how Fuel works with SolidFire.
Thank you very much, John. This is Ed Baldoff, a Cloud Solution Architect with SolidFire. I thought I had my title in the slide here, but I guess it's not showing up, but that's fine. So we're going to talk a little bit about how we at SolidFire have written the plugin and how it works with Fuel and can automate the deployment with SolidFire. At the end, I do have a video of how this all works. Of course, it's sped up a little bit, so we don't have to wait the 40 minutes for it to fully deploy, but we will take you through that. So I wanted to start a little bit. One of the things we see a big use for Fuel is in the enterprise business model. Now, John talked about service providers and some of the network function providers, and they have a business model that fits with OpenStack. They tend to be a little bit different in the way they do some of these. So this slide here that I have up kind of compares and contrasts the two models, although I'm going to talk about where the slide is, I guess, inaccurate a little bit, right? So, enterprises, it says here it's got a chunk about fully orchestrated for an enterprise model. Well, a service provider, that orchestration is there, but it just comes from the enterprises using their cloud model. The service provider, of course, has a more multi-tenant environment. The enterprises, the infrastructure is the enabler, where in the service provider, the infrastructure is the business, right? So we got another one here that says chargeback and showback. Of course, in the service provider, the chargeback is there. It's part of the model. It's how they make money. In the enterprise, some of that's important. Sometimes I find a lot of enterprise customers are not even doing chargeback, right? So there's a difference here. The enterprise tends to be, in theory, could deploy an OpenStack every day, use it for a while, and then pull it back and start another one. And that's where Fuel really comes into play. Also, it could be a number of different OpenStack instances, and Fuel can definitely manage multiple of those. So Fuel gives the enterprise some really interesting bits and pieces. It also provides a good foundation for the service provider to bring up the cloud, deploy the cloud, and then, as John talked about, maintain the cloud. So when you're in either of these businesses, how do you deploy storage, right? And this is where Fuel comes in, and then SolidFire is a big part of that. So I wanted to put up a slide here for those of you that haven't seen a slide like this before. This is the general layout of an OpenStack cloud. Very simple here with 2 controller nodes and 2 compute nodes. And then, of course, this shows the third-party storage. And OpenStack is getting so it has third-party storage and third-party networking. So you want to be able to configure all those all in one shot. SolidFire has been an integral part of the Cinder development, and so this model fits with everything we do. Basically, all the things listed under the controller node here are the things that Fuel will configure for you. It will also configure the base hardware to get that set up. And you just want to be able to make that auto deployment configure those to talk to the third-party storage. So in this picture, obviously they're separate, on separate nodes. Unlike everything that runs on controller 1 or 2, they talk within the node. Now we have to be able to configure this to talk across the network to that third-party storage. So, who is SolidFire? What is SolidFire? I'm going to jump here to a little bit of talking about what we do, and then again, how do we deploy it, right? So we're all about flexibility, control, how to mix workloads, multi-tenancy, and then time to value, right? So we'll kind of go through each of these here, but SolidFire is a scale-out storage system with a lot of flexibility. If you're building a cloud, you want to be flexible. You want to add capacity as needed. You want to be able to remove capacity as needed. You want to need for storage. You want to control how to interact with the cloud itself. We're very with OpenStack. How we make workloads. One of the biggest things you see in the cloud today is that performance is not. It's all different because the storage is going to lack use of how I can make sure that those workloads don't affect each other. And so what we bring to the table is the ability for a service provider, operator in the enterprise space to put guarantees around storage, and guarantees around performance, guarantees around capacity, and how do you add more capacity, add more performance as you need in the cloud. So let's go through a few things here. So the first of those is really scale out agility. And I like the little graphics in these slides. You guys can read the words, but as we show over here on the left, you start out with a 4-node cluster. It's upwards of 35 terabytes. There are some different options for how much storage is in each of those nodes. Each node is generally 50,000 IOPS. We have one node that provides more than that in a single node. But so you start out with this 4-node cluster shown in black, and you got 20,000 IOPS and 35 terabytes of storage. As your cloud grows and things get consumed, you can non-disruptively add in the gray node, which gives you another 50,000 IOPS of storage and 8-point-some terabytes as shown there. And then you add another node, the orange node, and you get 50,000. This is all non-disruptively. You do this during the middle of the day. You don't take down your workloads. You don't have to take outage time, service time. Upgrades happen the same way. We roll through the upgrades because if you're in a service provider, you can't go out to all your customers and take that time for those things. So we also support compatibility between different nodes, different versions of the operating system on those nodes, and we can do a rolling upgrade. So you don't have to wait for 3 years to upgrade your storage. You could just roll a node in. You can actually roll nodes out too, right? That's a great piece of it so that you can shrink the size of your cluster if you need to. So the next thing we do is really about high availability self-healing. Again, if you're in a cloud scenario and you've scaled, you need to embrace failure, and we do that in the storage realm. This is kind of unprecedented in the storage world where we embrace the failure and we got no single points of failure. If something happens, we self-recover from that. So we self-heal if a SSD fails. I say disk drive, but they're really solid-state drives. We maintain all the QoS settings. Everything that we guarantee is guaranteed no matter how much is working or if any failure happens. But we do auto-recover, so you don't have to call your service guy and have him run in a hurry. We've auto-recovered from that. The other piece of this, and I touched on a little bit at the beginning, was the ability to guarantee to every application, every user in the cloud a performance level. And this slide really talks about the noisy neighbor problem, and this is what we're trying to avoid. And on the left, you see here basically kind of chaos in the performance until all of a sudden the noisy neighbor comes in and demands a chunk of performance, and everybody else gets a lot less performance there. And then we go back to this kind of random noise until we turn on QoS. And that vertical bar kind of in the middle of the slide there, where it then talks about 1,000 IOPS, 1,200 IOPS, 8,000 IOPS for the different applications, is really where we turned on QoS. And by managing QoS through latency injection as we need to slow people down, the other applications all get to a much more consistent performance level. Not only are we guaranteeing performance, but we're providing that consistency. And if nothing else, customers want to be able to design for a consistent level of performance. So this is what QoS brings to you. Part of the question, and we'll show this is in a little bit deeper detail in the video, is how do you integrate this in with OpenStack such that your users of OpenStack can then select, I want these features and functionality, or these QoS settings, and provide that to their applications. So ideally it's a chargeback model. If you're this 8,000 IOPS application, you're getting charged a little more for your storage than if you're getting the 1,000 IOPS. And OpenStack provides all of that. And lastly, we have always-on deduplication, compression, and thin provisioning. This is what brings the cost and the ability to use solid-state flash storage down to the point where this makes sense. But it also helps in the cloud space where you have lots of replication. You have lots of operating system copies, so on and so forth. And by thin provisioning those, deduplicating them, and automatically compressing, we get 5 to 10x data reduction. We've seen some that are even significantly higher than that. We'll see some applications, typically VDI in a cloud, getting upwards of 50x deduplication or reduction in storage. So combine the value that SolidFire brings with making your apps able to run in a cloud, and then the value that Fuel brings, and how do we auto-deploy a cloud, how do we have that configured to automatically use SolidFire and bring those values in. That's what the plugin that SolidFire has developed with Mirantis around this really brings. It's one button. It's convenient GUI. Plugins for optional configs. So now, as John talked about, you can use Fuel and you can bring in all of these things. Different storage, different networking, different authentication, those kinds of things. It's all on a single pane of glass. We've got health check capabilities. And so, the SolidFire plugin itself brings all the configuration options necessary for SolidFire in an OpenStack cloud. It matches the OpenStack versions with the Fuel versions, and it's downloadable with a single click. So we'll take you through that in a video here in a second. In the meantime, I'm going to show a static picture. This is the plugin, what it looks like. You can see in the Fuel UI on the left, there's a bunch of options you can select. When you select the Fuel plugin for SolidFire, you get the set of boxes on the right that you would type in your IP address and your logins and endpoints and things like that. You can turn on, you can enable caching and some other configuration options. Again, we'll take you through a video. It'll be fairly quick here as it goes through the video, but that's the screen that you will work with. So back to a little bit of SolidFire stuff. Gartner has named us the #1 all-flash array for those capabilities, for scale out, for data reduction, those kinds of things. So that's been 2 years of running. And kind of a list of people that allow us to use their name that we as SolidFire are working with. We'll just leave that up there for you. Some of these are service providers, some of them are large enterprise, some of them kind of cross the two. So if you're running your stuff in a cloud today, there's a few of them that you may actually be running on SolidFire already. So now I'm going to jump to the video here, give it a second, and we'll run through this. I'm going to narrate this as it goes, so I may pause it momentarily to catch up my voice with the screens going forward here. So we're going to start by going to the Fuel plugin page and downloading the Fuel plugin for SolidFire. Then we're going to go through here and we'll copy that plugin to the machine where it needs to be. I'm going to run some commands here to install it. There's one command that installs it. And then I can log into the Fuel UI and create an environment. So we're going to go through all the steps that Fuel needs to create an environment. This could be one, or then you can create multiple, which are multiple OpenStack instances. And then here I'm going to set a couple things. I set debugging on, and we'll enable the SolidFire plugin and go through here and type in the relevant information. I'm going to leave a lot of this as defaults. And then we click Save. We go over here. This is where we pull in the roles for the different nodes. So we've set those as controller nodes. We're going to define 3 of those. We'll store that. We'll now bring in a single compute node here, apply those changes. Then I'm going to go over here, and there's a whole bunch of network settings, as John talked about, that need to be filled in. We'll do a couple of these, and then we'll speed up the video here so you don't have to watch all of it. I think you'll actually watch all of it, but it'll be amazing typing. This is setting up the storage network, the management network, the private network, the public network, so on and so forth. And then here's a little demonstration of the things that John was talking about with the drag and drop. So here I take those networks that I've defined from address numbers, I drag and drop those onto the different interfaces that are on those servers, and then I'm going to go back over here and verify the networks. So I went over there, I got a green, but that takes a little longer than it shows in the video, and then we hit deploy, and away we go. So with the power of and I'll pause the video here for a second. With the power of acceleration of the video, now the deployment has happened. So that kind of transition there was where it would have been the probably 40 minutes where it actually went out to those 4 servers. It put an operating system on them. It put the appropriate OpenStack components on those 4 servers. It enabled those components. It configured those components. And as part of this, you can see it configured the Cinder volume service to use SolidFire, and you can see that the SolidFire plugin declared success there. So we'll start this back up again. You can see here's the nodes. They're all deployed. They're all successful. Then we can go back and go to the Horizon UI and log into the OpenStack environment we've just deployed. And then we'll go in here, and we're going to just, as a simple test, I'm going to create a volume, and it will show that it's on SolidFire. So here we're creating the volume. We're giving it a size. It will go create it here in OpenStack. And then we can look at the UUID. Normally we wouldn't do this, but we're going to do it. We're going to go over to the SolidFire UI here and see that the UUID is up there in the SolidFire UI that came from OpenStack. So with that demonstrated that with that automated deployment, we got an automated configuration for SolidFire. And I think that's where I end the video. I did not show the QoS settings, but those are automatically carried over from OpenStack into the SolidFire also. So, and with that, I'm going to jump over to our last slide here, which is about questions. If there are any questions, please feel free to type those into chat. Let me go look and see what we have here. So, okay, we do have a couple questions. I'm going to read them off, and I'll either answer them myself or pass them off to John. Actually, the first one I'm going to ask is I'm going to read it and pass it to John, but either of us can answer this. So, what can a customer expect from Mirantis and SolidFire in terms of joint support experience? John, would you like to take that one?
Yeah, I'm happy to. Typically, for a product like this, it depends on what side of your installation the problem is coming from. Mirantis, of course, will support L1 through L3 on the cloud itself, all components of Mirantis OpenStack. What we generally try to do is provide L1 and L2 support on everything and escalate to the partner L3 issues. And in order to do that expeditiously, we found it's useful to use an intermediary, which is TSANet, which is an international consortium of multi-vendor support providers, collaborative support providers. What they do is they provide an infrastructure. They compel us to register points of contact that we maintain mutually transparent to one another, and they hold us to fairly strict SLAs. So they will enforce your desire to get answers to your questions quickly, and by complying with them, we can be sure that we have served your needs as a customer expeditiously. Ed, do you want to talk specifically about the the kind of L3 support that you guys would provide?
Yeah, so SolidFire is has a very robust support team here in Boulder, Colorado, mostly, although we do have international folks. We specifically stock our team with engineers. We try to stay away from the the L1 kind of what's your support contract and is it plugged in, and we go directly to a team of engineers. There are a number of them that are very schooled on OpenStack and Fuel and other things like that. So we're here to support you. We will support Mirantis, who's a great partner with us, and so together that experience should be seamless. With that, thanks for the pass back, John. I'm going to ask another question here that I see came in. Let's do this one here. Isn't all flash storage expensive? Why wouldn't I just run a software solution like Ceph on one of my compute nodes and put a couple of SSDs in them? Well, clearly we'd probably run it on a couple of compute nodes, but SolidFire and Ceph are somewhat on different ends of the spectrum, right? Ceph is an object storage that has a block component on top of that object storage. It's not. I don't want to say anything bad about Ceph. It's a great product. It's great at what it does, but it doesn't provide the guaranteed quality of service. It's very dependent on the underlying hardware to do some recovery capabilities, and it from what we've seen in our testing, when it does have issues, its performance can vary widely. The other thing that we see in a number of clouds is that you really want to separate your storage and your compute, because if compute is very taxed with workloads from customers and you take a failure in your storage, the storage then needs a bunch of compute resources, and so they're competing against each other. And so your determinism of your applications goes down when you combine the two. And so splitting off storage from compute is very important, especially in those compute and storage instances where you want very good determinism, very good quality of service, very consistent performance. And that's where we see a lot of our customers using Ceph and SolidFire together, where SolidFire is for those critical applications, tier 1, tier 2 storage, and then Ceph becomes the kind of the overall storage for tier 3 and or object storage. So let's see here. What others do we have for questions? John, here's one for you. Mirantis now, and I'll probably take part of this. Mirantis now supports OpenStack clouds that direct both VMware, ESXi, and standard KVM compute nodes. What would be the main benefits of equipping a VMware OpenStack dual hypervisor cluster with SolidFire storage, and how would you go about optimizing the deployment for cost and performance?
That's a very interesting question. Just to make the thrust of it, as I understand it, a little more clear, with our version 6, we have begun supporting. We've been longtime supporters of VMware integration, but until version 6, it was only possible to use Mirantis OpenStack as a controller cluster to control VMware ESXi compute and storage resources. Now it's possible to essentially build a scale-out OpenStack cloud using KVM compute and OpenStack storage alongside VMware ESXi compute and storage resources, and optionally use VMware storage for all storage in the cloud. So it gives you a lot of opportunity on the one hand to use existing VMware licensed infrastructure in a new and interesting way, to develop a common interface for DevOps and automation that drives your existing VMware plant, as well as gives you the opportunity to scale out without limit on commodity hardware under OpenStack using KVM. So if you are in the position of being a VMware shop but wanting to evolve your cloud and experiment in the current time frame with ways of lowering costs, for example, for compute capability, this provides a good avenue to loop all of that stuff together into a single infrastructure and really use what works for a while until your technology roadmap becomes more clear. I guess the hipshot answer to this would be, well, since SolidFire is VMware compatible, if I were a VMware shop, I would be investing in SolidFire VMware compatibility. I would put the SolidFire stuff on the VMware side, and I would use the option of providing the OpenStack cluster with all of its storage from the VMware virtualized storage infrastructure. Does that make sense to you, Ed?
Yes, it does, and actually, I'll kind of take the ball back here for a second. SolidFire is a solid partner with VMware, and so we have integrations with the VMware piece of it to provide storage from a single cluster to both VMware and to OpenStack. So it's a great solution. There are different characteristics of things in VMware, but we support all of those. So it's a great hybrid solution where you can run loads in either cloud and control those all from OpenStack. I'm going to read the next question here. So how do the question is, how do the QoS capabilities of SolidFire bring value to my business? Why wouldn't I just use storage without QoS, but that's very fast? And so I'm going to attempt to answer that here a little bit. So the big thing that I've seen in my career working with a number of vendors and a number of customers is that in a large scale application such as you would run on OpenStack, it's very important for a very defined amount of performance to come from every VM. If you have that super fast storage, you may fire up another VM to satisfy a load coming from your, the customer's customer, and you may get blazing performance out of it for 1 minute, and then the next minute as something else takes over or starts consuming storage and or compute resources, that VM then satisfies less requests and you have to spin up more. And so it's very difficult to characterize your growth trajectory, your build-out plans when you don't have that determinism in those applications, those VMs. So we have capabilities to do that at the CPU level. Storage becomes very, very critical, especially for database applications. If you look at some of the Web 2.0 customers like the Facebooks or the Instagrams or those kind of guys, as they scale up, they really need to understand what each database is going to perform at. They spin up another one. They want to understand that that's going to satisfy the next n number of customers, and it's not going to change. And that's where SolidFire really brings that value. This automated deployment brings that time to value down, and so you really helps set the determinism in the application. So,
this is John. Could I cross talk a little bit? I'd like to.
Sure, you can.
Follow-on question there. As you were speaking, it occurred to me that we really are talking. We are not talking about clouds in the main anymore that resemble the virtualization of legacy infrastructure. That is to say, we're not talking about clouds that run predictable, highly engineered, manually engineered, tweaked workloads, that are architected in for performance. We simply don't have that opportunity anymore because what we're doing is designing larger clouds that are virtualizing more infrastructure and making it instantly available to services that are rapidly deploying and scaling and self-serving those resources and capability to people in a way that, formally speaking, is not predictable. We really have to make everything policy bound, right? Like, for example, if we have a big Cloud Foundry installation running on top of our OpenStack or a big Kubernetes installation running on top of our OpenStack, some developer can start smoke testing something and push it, and it's running inside of 30 seconds in containers. and then they scale it out, and it's 10 times bigger within 30 seconds. And so, we're looking at potentially massively varying loads. So it makes perfect sense to me that it should be possible to request storage QoS as a function of all these rapid deployment, and auto-scaling things that we're using in order just to keep the weather in that cloud normal for everybody.
Yep, cool. I got one more question that just came in here, John, so I'm going to read that and then we'll be done. So can one SolidFire node group support multiple separate OpenStack installations or mixed environments? Example, where there is some manually served storage plus OpenStack automated storage. The answer to that is yes. We support, and we have in the driver as part of OpenStack some features to identify which OpenStack volumes are being created from, and we fully support that same cluster supporting VMware or manually configured applications. And it's all unswizzled through the GUI, so it actually works really well. We do it all the time here at headquarters, and so the person who asked that question, if you'd like to see more, please feel free to get a hold of us and we can demo how that works. And with that, I think we're at our time limit. We're actually 2 minutes over, so I think we'll wrap it up. And so thanks all for attending, and we'll look forward to catching you on the next webinar.